Hello fellow chemists. In this video we're going to take a look at drawing Lewis structures. This is labeled an intermediate level video because it assumes you have a basic understanding of covalent bonds and Lewis dot structures. If you need a review of those topics, I'll put a link in the upper right hand corner. So drawing Lewis structures, this occurs when you are writing covalently bonded compounds, and an example of a Lewis structure is kind of drawn at the bottom of the slide here, and it's just a way of showing the order in which the atoms are attached to each other in covalent compounds, often in organic compounds, carbon-hydrogen based compounds. So let's take a look at several examples of formulas and then convert those formulas into Lewis structures. So if we have CH4O, so again, we have a molecule here that has 6 atoms, 1 carbon, 4 hydrogens, and 1 oxygen in it. And you're asked to convert that into a Lewis structure. Again, the first thing you always want to do is draw out the dot structures. So we have hydrogens, the dot structure, and we have 4 hydrogens, and each one of those hydrogens is going to want to make 1 bond. And then if we look at carbon's dot structure, carbon will want to make 4 bonds. And then if we look at oxygen's dot structure, oxygen will want to make 2 bonds. Again, for oxygen, you only count the electrons that are not paired up as bonding electrons. So what you then do is, once you know the dot structures and how many bonds each of the atoms wants to make, you usually what you want to do, if it's carbon-based, you put carbon at the center of the molecule and then start placing the other atoms around it so that each atom makes the number of bonds that it wants. Each hydrogen needs to make 1 bond, the carbon must make 4 bonds, and the oxygen must make 2 bonds. So if we do that, let's make some space here. So we'll place the carbon at the center. The carbon's going to make 4 bonds, so we'll put a hydrogen on 3 of the 4 sides. Now if we put another hydrogen over here on the 4th side, there'll be no way to get the oxygen attached. So this third one will have an oxygen, and then the other bond of the oxygen will be to a hydrogen. And we don't forget to put in the non-bonding electrons. So we can see that each hydrogen is making 1 bond. The carbon is making 4 bonds, and then the oxygen is making 2 bonds. So all of the atoms are making the number of bonds that they want. We made sure to put in the non-bonding electrons of the oxygen, and we're all set for this one. So if we take a look at another example, we could have C2H2. Now again, for this one, if we look at the dot structure for hydrogen, each hydrogen will want to make 1 bond. To fill its valence shell, it has 1 electron. It can get to 2 electrons in its valence shell. And each carbon that we have will want to make 4 bonds. Again, if you have a molecule that has carbon in it, it's best to kind of put carbon at the center and then have the other atoms go around it. Gives you the best way to fill this out. So if we put, I'll intentionally do this one wrong initially. Let's say we put both hydrogens on 1 carbon, and then there's no hydrogens left, so we'll just say, okay, well, this carbon needs to get to 4 bonds, so we'll put another bond in there. Well, this carbon over here has 2 bonding electrons that are left, and it's only making 2 bonds. So this cannot work out this way. Even though this hydrogen is making 1 bond, this carbon's making 4 bonds, and this hydrogen is making 1 bond, this carbon over here is not making the number of bonds that it wants, and it has these electrons over here. These are radicals. Anytime you have a single electron that's not bonded to anything, it's a radical. And they do exist in nature, but they're not going to exist in any of the structures that we have today. So what we're going to do is take one of the hydrogens off of this carbon and stick it over here on this carbon. Well, now this hydrogen has one bond, this hydrogen has one bond, but each of the carbons only have 3 bonds. Well, just put another bond in between them. So now each carbon has 4 bonds total, each hydrogen has 1 bond, and the molecule is good. Now, as far as I've had students say, well, does it matter if I have this hydrogen kind of pointing up here and this hydrogen going out straight? For now, no, it doesn't matter. I mean, there are bond angles that these bonds are made at, but at this level of just beginning to learn Lewis structures, it doesn't matter if you put the hydrogen up here or if you put it coming off down here or this hydrogen down there or going straight across. All right, so that's C2H2. Let's take a look at one more example. So if we take a look at CH3Cl, if you want to pause it to try it on your own, feel free to do that. So the carbon, again, we look at the dot structure for carbon. It's going to want to make 4 bonds. The hydrogens, look at their dot structure, will each want to make 1 bond. And the chlorine, if you look at its dot structure, is going to also want to make 1 bond. And it's also important to know that the chlorine has 3 pairs of non-bonding electrons. And we want to make sure to draw them in when we do our final Lewis structure. So again, a good rule of thumb is if there's a carbon, kind of have that as the central part of your molecule. Carbon wants to make 4 bonds. There's 3 hydrogens and 1 chlorine. That's 4 bonds total. So we're just going to have the atoms coming off of the carbon. It doesn't matter which position you have the chlorine on. So you could have had it coming off the top or coming off the side. It's all the same. The chlorine in, and then don't forget to put in its 3 pairs of non-bonding electrons. So this would be the structure for CH3Cl. And then we're sure to put in the non-bonding electrons. The chlorine makes 1 bond, each hydrogen makes 1 bond, and the carbon makes 4 bonds. All right, that's it for this lesson. I hope you learned something, and I'll see you in the next video.